Our next problem is a sample of gas has a mass of 38.8 milligrams. Its volume is 224 milliliters at a temperature of 55 degrees Celsius and a pressure of 886 torr. Find the molar mass of the gas. So for this one, it's asking for the molar mass, which is in grams per mole. So we already have our mass, which is grams. We just need to convert that milligrams into grams. And so we're trying to find moles. So we need to look to see which gas law this might be. So in this case, it's going to be the ideal gas law, because the ideal gas law uses all these variables. So the ideal gas law is PV equals nRT, where R is equal to 0.0821 liters per ATM over moles times K. Now, since this uses the constant of R, we need to have all of our variables in these different units. So our volume must be in liters, our pressure must be in ATM, it must be in moles, and then temperature must be in Kelvin. So first, let's deal with mass, because we need to change our mass from milligrams to grams. So let's see, we have mass of 38.8 milligrams times, now there's 1 gram in 1,000 milligrams, so we have 1 gram per 1,000 milligrams. So our mass in grams is going to be 0.0388 grams. Next, we need to convert our volume from milliliters to liters. So our volume right now is 224 milliliters. And to convert this into liters, we have to divide by 1,000. So 224 milliliters is equal to 0.224 liters. Next, we need to convert our temperature of 55 degrees Celsius into Kelvin. And to do that, we need to add 273.15. So our temperature is now 328.15 Kelvin. Okay, the last one we need to convert is our pressure. So our pressure is 886 torr. Now we need to get to ATM. So from our very first problem in this slideshow presentation, 1 ATM is equal to 760 torr. So our ATM pressure is going to be 1.165789474. And I'm not worrying about sig figs just yet, so that's why I kind of have a long number going on here. Okay, so now we can find our moles. So we'll do this beforehand, before we start entering our numbers in. We can actually get n on the side by itself by dividing both sides by RT. So n is going to equal PV over RT. Okay, so now all we need to do is plug in our numbers. So we have our pressure of this really long number, 1.165789474, and a volume of 0.224 meters. Oh, I'm going to put in liters in. Okay, divided by our R value, which is 0.0821, and our temperature of 328.15. Okay, so we plug this into our calculator, we get 0.009692873 moles. So that's just the first part of the equation. We need to find the molar mass of the gas. So molar mass is in grams per mole. So we have our grams here, and now we have our moles. So all we need to do is do mass over our moles. So we have molar mass is equal to our 0.0388 divided by our number of moles of 0.009692873. So we do that equation and we get 4.00294. Now if we look at the periodic table, we will see that this particular sample of gas has to be helium, since the molar mass of helium is 4.00 grams per mole.